Okay, this is lesson 4.10, which is parallel lines. And so just a little bit about parallel lines. First of all, parallel lines have the same slope, and they can be really far apart, however, or really close to each other. However, they will never intersect. So no matter if they're really far or really close, they're never going to intersect, except for one situation, which I'll talk about later. So let's graph this one really quick. This is the line negative 1/4 x plus 1. So our y-intercept is 1. And then our slope is negative 1/4. So down 1, right 4. Down 1, right 4. And I'm actually going to go back and graph the other way as well. Up 1, left 4. So here's our line. Now a line that's parallel to this one will have a slope of negative 1/4 because remember they have the same slope. So now we need to draw a line that's parallel to this one but passes through negative 4, negative 2. Negative 4, negative 2. So if it passes through this one but it's parallel to this one, it will have the same slope, down 1/4. And there you have it. I can write the equation of this. Write the equation. The first thing I'm actually going to do is write the skeleton. The slope was negative 1/4. And now the y-intercept is negative 3. So that's the equation of a line that's parallel to this one and passes through negative 4, negative 2. Moving on. Okay. We're going to go through a little process where we're just writing equations on the graph. So let's first write the equation of this line. Write the equation, write the skeleton. The y-intercept is negative 1. The slope, I need to find another point, maybe here. I'm going to rise, negative 2, and then I'm going to run, positive 3. So the equation of this line, negative 2/3 x minus 1. Now we're going to draw a line parallel to this one, so it'll have the same slope, and passes through the point 6, 2. So let's go to 6, 2. And if it's parallel, it will have the same slope. Oh, that's good enough. Draw a line. I need to write the equation, which means I'm first going to write the skeleton. And if it's parallel, it'll have the same slope. And it passes through this point. Well, this was a line, and it has a y-intercept of 6. So now we need to just show that 6, 2 is a solution. If it is a solution, when I substitute 6 in for x and 2 in for y, it will make this a true equation. So I'm going to substitute 6, 2. Everywhere that I see an x, I'm going to put a 6. Everywhere that I see a y, I'm going to put a 2. So this will become negative 2/3 times x, which is 6. And then 2 is on this side. To simplify this, I put 6 over 1, and I can multiply straight across. Negative 12 over 3. Negative 12 over 3 is negative 4. Negative 4 plus 6 is 2. So since this is a true equation, this is indeed a solution. Now, why did I care about that? Well, we're not always going to be given graphs. In fact, most of the time you'll be dealing with problems that look like this. There's no graph. So we need to be able to do all this work without graphing it. So this says write the equation, so I'm going to write the skeleton. Of a line parallel, what does it mean to be parallel? Well, it means that they have the same slope to that equation and passes through this point. So since they have the same slope, I know that my new line will have a slope of negative 2/3. However, do I know my y-intercept? I don't. I, however, know a solution. So if I substitute 6 in for x and 2 in for y, I'll be able to solve for my y-intercept. Again, right now, I don't know b. That's what I'm solving for. I'm going to solve this at 6, 2. So everywhere that I see an x, I'm going to put a 6. And everywhere that I see a y, I'm going to put a 2. Again, this is 6 over 1, so I multiply straight across. Negative 12 over 3 plus b equals 2. 2 equals 12 divided by 3, which is a negative 4, plus b. To isolate b, I add 4 on both sides. My y-intercept is 6. And there's my equation. Let's go ahead and do another one. This says write the equation, so I will write the skeleton. Of a line parallel, what does it mean to be parallel? It has the same slope to that equation and passes through that point. So if this is our equation, I know that my slope is negative 4/3. I don't know my y-intercept. So to do that, I'm going to solve for it by substituting in the solution. Again, I don't know my y-intercept. That's what I'm solving for. Everywhere that I see an x, I'm going to put a 3. Everywhere that I see a y, I'm going to put a negative 5. This becomes here we go. We'll put the 3 over 1, multiply straight across. Negative 12 divided by 3 is a negative 4. Add 4 to both sides. Negative 1 equals b. And there you have it. Number 3 is a little bit different. Okay, you're going to write the equation of a line, write the equation, write the skeleton. Parallel, so this will be same slope to this equation that passes through negative 3, negative 6. Now, this is not in slope-intercept form. So what I first need to do is get in slope-intercept form, which means I need to isolate y. So I'll go ahead and subtract 4x on both sides. Y equals negative 4x plus 2. Now I know my slope is negative 4, and I can solve for my y-intercept. Everywhere that I see an x, I'll substitute 3. Everywhere that I see a y, I'll substitute negative 6. This becomes negative 4 times negative 3 plus b equals a negative 6. This is positive 12 plus b equals negative 6. We'll subtract 12 on both sides. Negative 18 equals b. My final equation, y equals negative 4x minus 18. You can check the answer to this one in the answer key. I'm going to move on to the next part, which is the whole idea that these are systems. So systems of equations that are parallel lines. So this is where things get a little funky, so you need to make sure you know what's going on. We're going to go ahead and solve this equation, this system of equations, using substitution. And let's see what happens. I see that my y term is isolated, so I'm going to substitute it into the second equation for y. Everywhere that I see a y, I'm going to substitute 2x plus 1. I'm going to distribute this 4 to both terms. Now I'm going to combine like terms. 8x minus 8x is actually 0 x's. And so I get 4 equals 4. That's not a solution. That's not what we know this as. And so this is kind of weird. So let's take a look on the graph and see what's happening here. I'll graph the first equation. Y-intercept is 1. Rise 2, run 1. Draw a line. So that's the first equation. The second equation, 4y minus 8x equals 4. I need to isolate the y, so I'll add 8x to both sides. Then I need to divide by 4. And I'll go ahead and graph this line in green. My y-intercept is 1. My slope is 2 over 1. So really, it's the same line. This system is 2 of the same lines. How many times do they intersect? An infinite number of times. So there are actually an infinite number of solutions. So what's the conclusion? If when you substitute and you find that the equation is true, what we would see as true, we're going to say this is always true, and therefore there are infinite solutions to this system because it's always intersecting. Really quick conclusion statement. If a system turns out to always be true, again, meaning things like 4 equals 4 or 6 equals 6, then it is 2 parallel lines. Again, it's 2 parallel lines because they have the same slope with infinite solutions. Okay, last one. This won't take that long. We're going to solve this using elimination. Add straight down. Positive y minus y goes away. Negative 2x plus 2x goes away. So I have 0 equals 1 minus 2 is a negative 1. So this is what we would call false, right? We would say that this is not a solution. So if you were to convert both of these into slope-intercept form, add 2x to both sides, equation 2, subtract